Let us continue with exercise 13b, question number 14. We have here the hollow right circular cylinder and the difference between the outer and inner curved surface area. We have only right circular cylinder but hollow. Hollow, that means it will be empty inside. So definitely we will have something inside and something outside. That means we will have the external cylinder and the internal cylinder. So if we have like that, that means we will have external radius, internal radius, and the difference between these two radius, it will give us the thickness of the cylinder. Okay, then in that particular cylinder we have the difference means we subtract the outer curved surface area and the inner curved surface area. It gives us 88 cm square. Then when they say 14 long, long mean here it will be the length of the cylinder. Okay, then we have another condition, the volume of the metal which make the cylinder, it is equal to 1676 cm cube. That means the volume, okay, is equal to 176 cm cube. So we have to find capital R and small r. So height of cylinder we know 14 cm, we give it as h. So we use what the question say, the outer curved surface area and the inner curved surface area equal 88 cm square. So the formula for CSA is 2 pi capital RH, that of inner 2 pi R, h still equal to 88. So if we see from here 2 pi h common, so we take common. From here we are left with capital R, here small r. Then 2 let it be 2, pi we know 22 by 7, h we know 14. So 7 cancel 14, we get 2. We want to find only this 2. So 2 into 22, 44, 44 into 2, 88. In 2, we take the side, become divide. 88 divide 88, we get 1. So that is equation 1. Then again we have the volume of the metal used in making that cylinder. It is equal to 176. So remember the cylinder, it is hollow. So that means there is something which we already take out. So that one we take out, we have to minus. The volume of cylinder is pi r square h. But we have to remove the inner cylinder. Okay, so that's why we remove r square. Still equal to 176. Then pi we know 22 by 7, h we know 14. Then here r square minus r, we can apply formula. So it will be a minus b, a plus b. So here we cancel, we get 2. Then r minus r, we get from here equal 1. Okay, so 2 into 22, 44 in 2. If you take the side, become divide. So here we can divide 176 divided by 44, we get equal to 4. Now here we have capital R, small r. Here we have capital R, small r. We need to solve them. So let us add them. So when we add left with left, right with right. So capital R and capital R both plus, it become 2r, small r, capital R, 1 minus 1 plus. So r minus r will be 0. Then here it will become 1 plus 4, which is equal to 5. So capital R will be 5 divided by 2, we get 2.5. In order to get small r, we replace it here. Okay, 2.5. This is minus, take the side become plus. This is plus, bring the side become minus. So 2.5 minus 1. 1 has no decimal. So we can minus from 2. That means r equal to 1.5. So we get the external radius to be 2.5. The diameter will be double of this. That means 5 cm. Then the inner radius we get 1.5 cm. So the diameter will be double. That means will be 3. So in order to get the thickness, it will become the external minus internal diameter. Okay, but we want only to find the outer and inner diameter, so we get it. Then next we move on to number 16. Here we have a cylinder bucket. Height is 32 cm. Then radius of base 18 cm. Then in that bucket we fill it with sand. Okay. And then after that we convert it to conical heap. So that means first we have cylinder, then we have a cone. Then the height of cone is 24. Radius and slant height we still have to find. So you see here at the beginning we have a cylindrical bucket. Okay, we have a cylinder, we fill it with sand. Then what did we do? This sand we pour it in the ground to form the shape of cone. So same, from cylinder we convert it to the shape of cone. So since it is converted from here to here, it means length, breadth and height will be different, but the volume of cylinder will be equal to volume of cone, because the sand which form the shape of cone, it comes from the cylinder. So let us make use of that fact in order to solve what is needed. From the question, clearly we can write volume of sand in the cylinder. It is equal to volume of cone, which form the shape of sand. So volume of cylinder, the formula we know pi r square h. That of cone also 1 by 3 pi r square h. Pi common, we can cancel. R different, we replace. Capital R we know 18. Okay, since we have square, put twice. Then small h we put 32. Then 1 by 3 into small r, we still have to find capital H, we have 24. So 3 divide 24, we get 8. So here it is in 2. If you want r, we have to divide the other side. Okay, so 8 divide here, we have 4. Now we want only r, so you put square root. 18 and 18, two of them, we take out 1. Then 4, when we take out, it will become 2. So 2 into 18, it is 36. Now the radius we get, we have to find the slant height. So we know slant height we have to use like Pythagoras theorem, right? We have like that. This is a slant height, which is hypotenuse, perpendicular height and radius. So L square equal to h square plus r square. L square h we know 36 square, r we know 24 square. So multiply 36 into 36, we get 576. 24 into 24, 1296. So if we add them, we get 1872. So using long division method, you can find the value, which is not exactly, but approximately you will get it 43.26 cm. So now we get the slant height, we get the radius, that's it. Next we continue to number 18. There are around 150 marble. The diameter of the marble is 1.7. Then they are dropped. So marble take the form of sphere. There are 150 of them, that means small one. Then we have one tanky in the form of cylinder, which is full of water. The diameter is 7. Then the height also will be there. So what happened? All this 150 marble, we put it inside here. So if you put it inside here, what happened? Definitely the water which is here, it will, if the water is little, it will go up. If the water is more, then it will be overflow. Here they say that a cylindrical vessel of diameter, this one containing some water. So there are only some water here. Okay, so when we put those 150 marble, where water will reach? Maybe at the beginning here. Now, so if you drop some marble, definitely it will go up. So remember why it go up? Because of the presence of marble. So what we can conclude, that means the volume of the cylinder will be equal to the volume of the water raised in this particular tanky. So why the water raised? Because we drop the marble. So that means the volume of the water replaced here should be equal to the volume of the marbles. So there, and mean from the question we can clearly write that the volume of water, it will be equal to the volume of the sphere, but since there are many of them, we can put with n. So volume of sphere we know pi r volume cylinder pi r square h, and that of a sphere n, let it be n, 4 by 3 pi r cube. Then if you compare pi we can cancel. Small r we know 3.5 into 3.5, then h we still have to find. Then here n we know 150, 4 by 3. Capital R we already have it as 0.7. Okay, so here we cancel, we get 50. Then we want only h this multiply, we can take down this side. So try to remove 0 or decimal by putting 0 up, and to remove decimal up we put 0 down. Then we cancel, finally we are left with 28 by 5, and if we divide we get 5.6 cm. So that means the water in the tanki raised by 5.6 cm because we dropped those spherical ball.